convex pentagon ABCDE has side lengths AB equals 5, BC equals CD equals DE equals 6, and EA equals 7. Moreover, the pentagon has an inscribed circle, a circle tangent to each of the 5 sides of the pentagon. Find the area of ABCDE. So we got pentagon ABCDE here, which has side lengths 5, 6, 6, 6, and 7. And it's also constructed so that it has an inscribed circle, which is tangent to each of the 5 sides of the pentagon. And we need to find the area of pentagon ABCDE. And this would be easier if we formed 5 triangles, which all meet at one point at the center of the circle. So this is the center of the circle, let's call it O. And we form triangles OAB, OBC, OCD, ODE, and OEA, which all meet at O, the center of the circle. And the area of the pentagon is just the sum of the areas of these 5 triangles, which each have a base length equal to one of the sides of the pentagon and a height equal to the radius of the circle. So the total area of pentagon ABCDE is equal to 5r over 2, that's the area of triangle OAB, using the 1/2 base times height, 5r over 2 plus 6r over 2, plus 6r over 2, plus 6r over 2 again, plus 7r over 2 for triangle OEA. And this is the area of pentagon ABCDE. It's equal to 30r over 2, which is equal to 15r. So all we need to do is find the value of r and then multiply that by 15. Let's write that here, 15r. So how do we find the value of r? Well, we can draw in every single height of a triangle, OAB, OBC, OCD, ODE, and OEA. And those are all equal to r. Now the value of r can be more easily determined if we know all the lengths, the other leg lengths in the triangles they are connected to. And we have to know the tangents from each A, B, C, D, and E if we are to know the other leg length of each triangle. So let's call them A, B, C, D, and E, little a, B, C, D, and E. The tangents from A have length little a, and similarly for B, C, D, and E. So we get that A plus B is equal to 5. B plus C is 6. C plus D and D plus E are also 6. E plus A is 7. And if we add these, we'll see that each of A, B, C, D, and E appears twice. So A plus B plus C plus D plus E is just 5 plus 6 plus 6 plus 6 plus 7 over 2, and that's 30 over 2, which is 15. So A plus B plus C plus D plus E is 15. From here, we can determine each of A, B, C, D, and E. A is equal to 15 minus B plus C and D plus E, which is 15 minus 6 minus 6. And that's equal to 3. B is equal to 15 minus C plus D and E plus A, 15 minus 6 minus 7, that's equal to 2. Now C is equal to 15 minus A plus B and D plus E, which is 15 minus 5 minus 6, and that's equal to 15 minus 11, which is 4. D, meanwhile, is equal to 15 minus E plus A and B plus C, 15 minus 7 minus 6, which is equal to 2. And finally, E, that's just equal to 15 minus A plus B plus C plus D, which is 15 minus 5 minus 6, 15 minus 11, which is equal to C, 4. So we have A, B, C, D, and E are equal to 3, 2, 4, 2, and 4, respectively. So we can now update A, B, C, D, and E with those values. 3, 2, 4, 2, and 4. And if you see, the sum of the length on each side still adds up to 5, 6, 6, 6, and 7, which is what we expected. So we know that these lengths are correct. Now here comes the fun part where we determine the value of r. In order for this configuration to be valid, we need the sum of the central angles to be 2 pi, or a full circle. That is the sum of these angles here. That's 2 pi. But we can also express them as an arctan. Each of those angles is an angle in a right triangle that's opposite one of the tangent lengths. It's the arctan of that tangent length over r. So for example, this angle here is equal to arctan 2 over r. And how many such arctan 2 over r's are there? Well, there's 4. It's this one, these 4, basically. And arctan 2 over r is simply the argument of a complex number equal to r plus 2i. And if you raise that to the 4th power, the argument will multiply itself by 4. And since there's 4 arctan 2 over r's here, this works. It's the complex number r plus 2i to the 4th. There's also 4 arctan 4 over r's. So that's r plus 4i to the 4th. And then there's 2 arctan 3 over r's. So r plus 3i squared. And if the argument of this complex number is equal to 2 pi, that means it's a real number. So it has to be a positive real number, that is the square of another real number equal to r plus 2i squared, r plus 4i squared, r plus 3i. This is a negative real number since it has argument equal to pi. So we just want the imaginary part of r plus 2i squared, r plus 4i squared, r plus 3i to be equal to 0. The number of times I shows up in the end is equal to 0. So let's expand this product and see what we get. R plus 2i times r plus 4i is r squared plus 6ir minus 8. We square that and then multiply it by r plus 3i. Now remember, if we want to square a plus b plus c, it's just a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. And if we apply that here, it's r to the 4th minus 36r squared plus 64 plus 2ab, that would be plus 12ir cubed plus 2bc would be minus 96ir, and then plus 2ca, well, that's just minus 16r squared. And we have to multiply that by r plus 3i. We have r to the 4th plus 12ir cubed. How many times does r squared appear? Well, it appears minus 52 times, because minus 16 minus 36. Minus 52 r squared. And then ir only appears once, minus 96. Plus 64. We have to multiply this by r plus 3i. Let's see what we get. So if we multiply by r, it would just be r to the 5th plus 12i r to the 4th minus 52r cubed minus 96i r squared plus 64r. But then comes the 3i. So multiplying 3i times r to the 4th would give you this, plus 3i r to the 4th. 3i times 12i is minus 36, so minus 36r cubed. And then 3i times negative 52r squared, that's minus 156ir squared. And then 3i times negative 96i is 288. So plus 288r. And then finally we have 192i. So let's add this. R to the 5th plus 15i r to the 4th minus 88r cubed minus 252i r squared plus 352r plus 192i. And we need that the imaginary part of this complex number is equal to 0. In other words, it's a real number. So how do we do that? Well, we just make sure the number of times I appears is equal to 0. And how do we get an expression for the number of times I appears? Well, it has to come from one of these three terms. So it's just 15r to the fourth minus 252r squared plus 192. That's the number of times I appears, and it should be equal to 0. Now divide by 15, you're going to get r to the fourth minus 84 over 5 r squared plus 64 over 5 is equal to 0. And this factors as r squared minus 16 times r squared minus 4 over 5 equals 0. So if r squared equals 16, then r equals 4. If r squared equals 4 over 5, then r equals 2 over root 5. The area of the pentagon is 15r, as we said earlier, and this has to be an integer because it's the AIME. So we cannot have r equals 2 over root 5. Then 15r is equal to 30 over root 5, which is 6 root 5. And 6 root 5 isn't an integer, so that's out. R is equal to 4, and the area of the pentagon is 15r, which is equal to 15 times 4, and that's equal to 60. Thank you for watching this YouTube video, and please follow my channel if you would like to see more videos. It's exactly 1 month until the AIME I on February 1. Please help us get to 375 followers before the AIME I.